I'd like to tell the story as to how we got into additive manufacturing, or 3D printing. Additive manufacturing is what we prefer to call it. We're the first company in the UK to have additive manufacturing in our company name. So basically, what we're going to look at is Croft filters, the background, conventional filter manufacture, how we got into additive manufacture, filter design, and the innovations and the opportunities that has offered us as a company. So basically, as a group, we're employing 23 people. We're turning over £1.5 million to €2 million. And we have 40% returning customers. Sorry, we have 40% new customers and about 60% returning. We have no standard products whatsoever. We have no production line, as you'd recognise a conventional production line, and everything's handcrafted. What we do offer is we offer customers bespoke solutions for their filtration problems. So we're very, very lucky in that we get people phoning up saying, I've got a problem, it's a filtration problem, can you solve it please? So that gives us an opportunity to do things our way and to get the customers satisfied. So basically, for the last 29 years, we've been working with woven wire mesh, perforated plate as our main filtration ingredients as such. We also have wedge wire and some knitted mesh that comes along. Basically, most of our stuff goes out as cylinders or witch's hat configuration, and there's a limited amount in flat panels. On the conventional process, all my life I've been asked for strength and open area. Conventionally, those two don't go together. You either have a product that's strong with limited flow, or you have open area that just hasn't got the strength. So what we do in the main is anything that's perforated, we perforate in-house on trunk punch presses, and that gives us solid areas to weld to. It also gives a solid area to weld the mesh to, which is a resistance weld normally, and this gives a quality, so we're guaranteeing a seal, and there's no bypass in what we do. There's filters that go in to out, filters that go out to in, but it's designed to what the customer needs is what we supply. We realise that the pressure drop across the filter is an important factor, and 13% of the UK's electrical energy is used in pumping, which is around 6% of the UK's carbon footprint. So my brother had the great idea that if we could look at doing something with the filtration and put the holes in line, then we could reduce the amount of energy required to pump anything through a filter. So we tried lots and lots of different things. We tried drilling. We knew what we knew what we were trying to do. We knew we were trying to get the holes in line. So the CAD drawing was literally an outer ring and then a selection of circles looking at it end on. But like I say, we tried drilling, we tried laser, but the laser wasn't, couldn't get in tight enough. We tried punching with a lip and an indentation on the back end of the hole, but it just wasn't to be had. It was just impossible to produce. Luckily enough, I was at Fab Lab one day on a management training course, and we were trying to get an egg from A to B in the shortest possible time. Luckily, I noticed a plastic 3D printer in the corner, and at that point I realised that that could possibly do what we were looking for. So that gave us the opportunity to put the holes in line, as opposed to a conventional filter where the product's travelling along the stream. It's got to take a left turn, got to take a right turn, and then move along with the flow. By putting the holes in line, and the first plastic ABS product looks something like that, so it gives us clean flow through, and we were able to do that in a plastic product, which got us thinking as to where do we go to next. We were lucky enough to engage with a project in the UK, which is a three-way partnership. It's called the Knowledge Transfer Partnership, and it involves a university, a graduate and an SME. And basically, the university kind of put the programme together to line up with what you want as an SME, and the graduate comes and does it with the supervision of the university. So we were looking at putting into place a test rig and developing this type of filter, which would give the improved flow. At that point, we started looking at additive manufacturing. We knew that plastic wasn't where we were at. Most of our stuff's in stainless steel. So we looked at additive manufacturing, and we were looking what it could offer us as an SME. So we identified that there's the design freedoms, less labour, the prototype production would be absolutely ideal for what we're doing, in that most of our orders, the most common number that appears on an order to Croft is the number 5 of. So we're making small batches, so additive is beautiful for this. So we're looking at what materials we could use, what the time was, and could we take multi-product components down to single product, and it gave us lots of opportunities for innovation. We had a quick look at the Gartner hype cycle, and we realised that where we were was on the rise, first generation. We kind of were thinking that we were ahead of ourselves, and when we look at the Gartner hype cycle in 2011, we've got the plastic 3D printing on its way up on the technology trigger. No mention of metal as a separate item on there. They just lump everything together as the 3D printing. So at that point, we decided to take this huge step, bearing in mind we are only turning over €2 million. We decided to invest in an additive manufacturing machine. And because we'd had some work done by the Design Council based in the UK, we went from being a partnership where the big boys couldn't see our accounts, and we then went to two outfits, which were Croft Filters Ltd and Croft Additive Manufacturing Ltd. So we've now invested in a Realizer 250 machine. Why did we get a Realizer? We looked at quite a few of the producers that were around at that stage, and the choice for the Realizer was because it was the best machine in those days for putting two layers next to each other, leaving a control gap. Basically, we sell apertures, so it wasn't how good the finish was when you put everything together, it was how good the finish was when you had two manufactured lines that were separated. So we've got a Realizer 250, which means the build box is 250 by 250 by 300 milli deep, and we decided that we're going to run stainless steel 316 as being the only product that we would run in that machine. Now, whilst the manufacturers say it can be changed, and we fully agree with them, to actually change the material over on that type of machine is not easy, and If you came along with a £50,000 order, then we'd switch to titanium tomorrow. But as we are at the moment, we're looking purely at stainless steel, and we don't think it's worth the risk of changing that material in that machine. Given our time again, would we buy the same machine? Perhaps not. Perhaps we'd have gone for a cheaper machine that offered a powder change, so we could change the materials. Perhaps that's something that we would have looked at. Ask me again in 2 or 3 years' time, and I think we might say we made the right choice for the realiser. So additive manufacturing, firstly, it is not plug and play by any way, shape or form. We're lucky, we're fairly innovative. My business partner and your fellow director are fairly switched on with the CAD side of it and also the laser tweaking. We got a machine that was fully open to us in that we can adjust all the parameters, and we do get support from Realiser for that, but in the main we control that ourselves. So the variables for the laser is the intensity and the duration. For the powder, the type of powder, which we show stainless, and the layer thickness is. There's also decisions to be made on the support structures, the angle of the build and the design. We actually use materialised software which puts the support structures in for us, but there is a bit of flexibility in that we can redesign the support structures that are automatically generated. For the innovation areas, we thought that filter design was the obvious thing that we were going to move forward with, but we're also looking for other products. Croft Additive Manufacturing is looking for other products to build and to get involved with. We have now got what we call the straight liner filter, which is the one with the holes in line. And the additive gives us the opportunity to, it's scalable. We can go from a small one right through to anything that fits on a 10-inch build plate by 12 inches high. So there really is scope for doing things. What we have to look at, though, is there's part of apart from not being plug and play, there's the dirty secrets. So we have the support structure. So because this filter it's got a domed end on it, it needs supporting. If it was at 45 degrees, it would be self-building, but because it's domed, there's the centre point that needs a support. So the dirty secrets have us creating this support structure up the middle, which is just there to allow the build to go over the top. So the hype of you using everything is not true. That's just a scrap that's generated during the process of building that filter. The straight liner filter actually it does offer improvements. The pumping energy is reduced from the conventional, the fluid flow rate increases. So, we are definitely doing something that is going the right way, and, it's offering decreased carbon footprints to the end users. We were lucky enough to be picked up by CERN, in that locally the Science and Technology Facility Council had a joint venture with CERN out in Switzerland, and we were the first company to be on a business incubator, and we get support from CERN, and we're putting stuff into CERN at the moment, and we're having that tested. A lot of the stuff they do is on vacuum engineering, and we're having the products now passed. So we're having additive products in stainless steel now passed for use on vacuum engineering. That's quite an achievement for us. We also do quite a lot of work with Lancaster University, and they've supported the trip here today. And the UK, what was the Technology Strategy Board, now called Innovate UK, has given us 3 different grants for working on additive manufacturing. The one we're currently working on is a finishing grant, because basically the first couple of years filters didn't need finishing. We're not looking for the finishing on the filters. So now we're working on it's a £100,000 grant that we've got for working on finishing of additive manufactured products. As part of our development in the 3D, we've got patent pending, and we're building filters with different node sizes. We started off with a 0.5 node and go into a 3mm node, and the nodes basically consist of an arm, the node centre and the node length, and that you will see as a support structure. But we're converting that to a filter application, and we've got different things going on there. The integrated support and mesh really does change the thinking on the filter design. It gives so much more strength with open area that just cannot be obtained by conventional manufacture. So, whilst the cost is slightly higher, for a whole-of-life situation, these filters have got a lot to offer. If you take wedge wire as a product, this is something we don't actually manufacture ourselves, but we do sell quite a bit of, and it's a bought-in product to us with a lead time of 4 to 6 weeks, which absolutely kills us in that 60% of what we do goes out in 6 days. So to actually have a product that we've got to wait 4 weeks for the raw material to arrive before we can do anything with it is a real killer. So we've started to look at what we can do with wedge. And normally on a wedge product you'd have a fitting at one end, a threaded fitting perhaps, with an end cap on the other end and the wedge tube in between. A real problematic thing to weld up, because you've got a spiral of wedge that tapers to nothing. You go to that with a TIG torch and it just disappears on you. You're chasing the thing round, you're putting filler in. It's not good. What we've been able to do with AM is build one-piece construction, and this is built, it's built that way up, and as part of the dirty secrets, it's available to see afterwards, we've got a slightly messy face there which was attached to the build plate. We've actually got a slight problem with there's a step there which has happened because on the build there's that much heat going into it, it's pulled it in. So we know about that now, so what we do is we build at 92 degrees, so when it is pulled in, it meets up perfectly with the support ring that's going round. So, we're back to dirty secrets of additive again. There are things to be very much aware of. But that gives us a multi-part to a single parts product. We've also got these here are custom made. Customer takes 4 of as a batch. That's his order. We build a spare one. He wants to, if he wants to alter the size, we can alter the size. He wants to alter the fitting, no problem. We can just alter that. It's just a CAD thing before we could do the build. We recently had a local company who make ball mills. They had an order going out to the States. They'd been let down by the wedge supplier. They came to us and said, "What can you do?" We designed something that was completely different. We put the support on the outside, so that's going from in to out. We did the design, we had it produced in 2 days. Customers absolutely delighted, couldn't believe it, because like us, he was used to having wedge in 4 to 6 weeks. And, you know, he's repeated on us several times since. Another product we have is, and as a standard conventional product, it's a way of making a woven wire mesh disc safe. So we put a U-section edge onto the disc, which makes it handleable, and you haven't got the sharp edges. The problem is when you're doing this, you've got a U-section and you've got the mesh going into it. You've got bug points, trapping points there, so cleaning it is an absolute nightmare. We very, very easily switched that to a AM product, and basically we're building a solid rim, so there's no, you know, it's not a U, it's solid. The actual meshes are square apertures, so we haven't got the overlap with the bug traps on the way on the woven. We've just got the square apertures, which are relatively easy to clean compared with the conventional product. We do quite a bit of combining. Customers aren't really ready for additive manufacturing yet. If you tell them it's an additive manufactured product, sometimes they're very, very wary of it because they think it's untested. Quite often we use additive without telling the customer that it's an additive component in there. So here we're using it's a relatively easy inline strainer to put into place, and it's got quick release, so you can change the filter element or clean it out. And we're using this as the holder for the woven wire mesh. There you can just about make out it's got a square grid behind it, and the big advantage is that you can change the mesh size very, very easily. You just flick the mesh out, put another mesh in. So if the customer doesn't know what size he wants to filter at, this is a great way of testing. And we're also getting an additive product into the marketplace. So when we're speaking to him later, we can say, oh, the support, the mesh holder, that's an additive manufactured product. So we are getting the product out there in a discreet sort of manner. So what have we got from additive manufacturing? We've got new products that have come along, and we've got new manufacturing processes, and we've got improved filtration. We believe that additive is a fantastic thing. The world's not ready for it yet. Finland seems a little bit more advanced than the rest of the world. I personally believe that we'll go from having half a machine too much to being 7 machines short in the period of a week. I just don't know which week, but I think it'll happen. One of the things that Croft Additive have hit on is the development for a designer who's manufacturing shoes. This designer identified the fact that it was 100 years since the trench boot was used in World War I, and he wanted to combine that technology with the latest technology available. So he came to us and said, what can we do on additive manufacturing to bring these shoes up to date, but basically working on the old design. So we made the shanks for him. It took quite a bit of developing. It was literally straight off the back of a fag packet. It took us about 6 or 8 goes before we got something that was absolutely right for him. There was issues on sewing, and that needles were snapping if they weren't going in the right place. But eventually we got there, and we managed to do it as a low volume production run. I think there's 80 on the build plate there. It's a high value product, and it repeats. These are the shoes If you're in London, just nip down to Savile Row and there's a pair there waiting for you. Just take a lot of money with you when you go. And that's what they look like with the additive stainless steel components built into them. So you've got the shanks, the toes and the heels. What industries are we working with? The market sectors that we are hitting is marine, pharmaceutical, automotive, space. We're lucky enough to be working with the UK people on a grant for doing a product that's going into space. We've got the shoes. We have safety showers. That's a real interesting one because the actual machining of the shower head is an absolute nightmare, and it can be done relatively easy with additive. The only problem is additive's not ready to build in the quantities that the industry requires. We're also working in oil and gas and some medical instrumentation. We're bringing on different product types on a year-by-year basis, and it is quite interesting to be involved. So Gartner now has produced his own his own graph based on where the market's up to, and I agree with some. The crazy thing is, the risk-averse industries, which are the medical and the aerospace, they've gone through all the hard times. Dental, I totally disagree with dental. I think that dental should be down here somewhere because dental's been around for a long time. But there's a lot of stuff on the technology trigger side, and it'll be interesting to see where that goes to.